I put together some long overdue videos today on electricity and what we need to know about it. We'll start with a video about static electricity, one of the two types of electricity we need to know about, the other type being current. Static electricity is the buildup of electrons on an insulator. Again, electrons, we've talked about these before. Electrons are one of the three major subatomic particles. There are protons, neutrons, and electrons. Protons and neutrons are found in the nucleus of the atom. Electrons are found outside that nucleus in an electron cloud. Electrons have a negative electrical charge. With the smallest of three subatomic particles having almost no mass, all of electricity involves electrons, thus the name. Insulator is the other word in here that's important, and one of the newer ones in this particular unit. Insulators are substances that resist the flow of electrons. In other words, electrons cannot move through them very well. These are called insulators. These are what you find on electric poles. They separate the electric wires from the poles themselves, preventing electricity from flowing into those poles. They're made of plastic, ceramic, or glass. All those substances are good insulators. They prevent electrons from flowing through them well. Here I've got a picture of wiring, and on the outside of the wiring you have a coating of plastic. That plastic is an insulator. Plastic prevents electrons from moving from the wire into you or whatever else happens to touch that wire. The ones that we'll be looking at here as we talk about static electricity will include balloons. Balloons are made of latex, a type of synthetic rubber, plastic. Again, electrons cannot flow through it very well at all. And materials like wool or hair, those again being insulators, electrons don't move through them well at all. The main thing you need to know about static electricity is how you produce a static charge. And there are three ways in which we can produce that static charge. There's friction, induction, and conduction. And what I'm going to do here for the remainder of the video is talk about these three things, how they work, and give you some examples of them. We'll start with friction because I think it's the easiest one to understand. We've talked about friction before. Friction came up when we talked about moving objects and forces that act on moving objects. Friction was a force that opposes motion when two surfaces rub together. In the case of static electricity, friction still does involve rubbing. Friction involves rubbing two insulators together to produce a static charge. One of our objects will become positive, the other one will become negative. What we basically do is take the force of friction and rub electrons off of one object onto the other. And a great example of that is rubbing a balloon in your hair. When you rub a balloon in your hair, the friction between the balloon and the hair literally rubs electrons off of the hair and onto the balloon. When that happens, the balloon becomes negatively charged because of all those electrons that have been rubbed onto it. The hair becomes positively charged because it lost electrons. This is very much like ions and how ions form. We talked about when atoms lose electrons, they become positively charged. Well, the hair is losing electrons, it becomes positively charged. We talked about how when atoms gain electrons, they become negatively charged. And here, the balloon gains electrons, it becomes negatively charged. Through friction, we start off with two neutral objects. We end up with two charged objects. One of them negative, the other one positive. Induction is another way we can acquire a static charge. Induction involves using a negatively charged object, like that balloon that was rubbed in the hair, to force another object to become positively charged. This time, however, it doesn't involve rubbing at all. In fact, they don't even have to touch for induction to take place. Induction is the only one of these methods of acquiring a static charge that does not involve contact. You use the negatively charged object to force the other one to become positive. If this negatively charged balloon is brought near a wall, it can be stuck to the wall. And the reason why it will stick, the reason why it'll cling to it, is because the wall becomes positively charged. The balloon is negative. And what happens is when it approaches the wall, it makes the electrons in the wall's atom move deeper into the wall, move away from the surface, leaving the surface of the wall positive. And when positive and negatives get together, they stick together. They're attracted to each other, just like it was when we dealt with ions. Again, we're not rubbing these two things together. You don't have to rub the balloon against the wall. That is one of the things that makes it very different from friction. And this whole process happens before they ever touch. As the balloon is coming closer and closer to the wall becomes more and more positive as its electrons are forced away. The third and final way of acquiring a static charge is a process called conduction. In conduction, you use a negatively charged object, like a balloon again, to make another object negative this time. And the kicker here is it happens through direct contact when they touch each other. If we take a negatively charged balloon and we bring it near a neutral one, we actually allow it to touch that neutral one, some of the electrons will jump from our red balloon to our green one, or negative one to our neutral one. It's a simple matter of repulsion. All these electrons are somewhere they don't want to be. They have nowhere to go because they're on an insulator. When this neutral object touches it, there is a place to go that has less repulsion, so they jump there, making that neutral object become negatively charged. We pull these two balloons apart. This neutral balloon has become negative. The one that was originally negative stays negative. We have charged this balloon through direct contact with a negative object. Some major things to consider: what you start with, what you end with. In friction, you start with two neutral objects. You end with a positive and a negative. In induction, you start with a negative object and a neutral object. The negative one was the balloon, the neutral one was the wall. When they're done, the balloon stays negative, the wall becomes positive. Again, remember, this one does not involve direct contact. It's the only one that doesn't. In conduction, you start off with a negative and a neutral, and when it's all done, they both become negative. So there are some similarities to them. There are some differences to them. Those are the things to focus on to make sure that you remember them, to make sure that you can differentiate between them. As always, if you have any questions, please post them on the wall or ask me in class.